All right, let's look at this last lesson here. Actually, grade 11, sorry, again, before I start, I am going to split this one up into two pieces again as well, for a slightly different reason, mostly because this lesson is like 5 or 6 pages long and it would take me forever to do it in one video, so let's break it up into two pieces. Okay, so we're going to put all of our skills together now that we have on linear relations, and that means we're going to be moving towards some more word problems, so if you don't love those, I'm sorry, but we do have to deal with those in this unit. Okay, so we are going to start with those two blanks there, okay? And so when we start an equation, or write an equation, create an equation, we always want to look for two things, which are the starting point, okay? I'm going to try that again. There we go. The starting point. And the slope or the rate of change of the second is the second thing that we always need to be able to determine. Okay, so there we go. Okay, those are very important things with graphs, so that's why I wanted to make sure we had them here right away, so that you can always look back on them when you're doing some word problem practice. Okay, so let's do our first problem here. So one morning there were 20 inches of snow on the ground, presumably. The weather started getting warmer, and by day 2 there were 18 inches of snow, and on day 3 there were 16 inches. So the pattern continued until there was no snow left on the ground. So the first thing we want to do here is identify the independent and dependent variables. So if you think about this, we can see that the weather is affecting how many inches are left on the ground, right? And so because of that, we can say that the independent, which I like to abbreviate to in-depth because I'm a little bit lazy and don't want to write too much, is the weather, right? So nothing is going to change the weather that we can do, and certainly not the snow on the ground, right? Like the amount of snow is not telling us how the weather will change. It's just saying that when it's cold, snow falls, and when it's not cold, the snow doesn't fall, right? But the snow amount does depend on the weather, because if it's warm enough, it will melt, right? So that's what we are looking at here. Okay, so the inches of snow, to be specific, depend on the weather. Okay, and maybe we can even say on the ground, because that really is the case, how much snow is on the ground. All right, so we're going to complete a table of values, and I wrote below, but I forgot to put the graph in, so my bad, or the table, sorry. So let's make that together, okay? So we're going to start, there we go, with there we go. Okay, so we are going to start with the weather. Okay, so, or the day, right? So the number of days that have passed. Okay, I'm going to add that to our independent variable, because also the days that have passed will indicate that the weather is getting warmer, right? So as the days pass, the weather gets warmer, so then the snow melts, and so the days that have passed will be here on our first column, or first row, pardon me, and then the inches of snow will be the other, the other thing that we're examining. Okay, so we can see that on day 1, there are 20 inches of snow, and I'm just reading that right out of the problem. Okay, so one morning there were 20 inches of snow. Okay, first day, that's what we have. Then we're going to look at the second day, and we're going to see that there were 18 inches of snow at the end of the day. Then on the third day, there were 16 inches. Again, I just took those right out of the problem. Okay, and now by this point we have a pattern, right? The pattern continued, and so we're going to figure out that pattern and then continue it in order to figure out how many days it took for the snow to disappear. Okay, so I'm just going to draw a few lines in here, and then we'll start filling this in. There we go. I actually don't know how many spaces we're going to need. I'm just kind of drawing right now, and you guys can feel free to do the same. Okay, well, that's close to enough anyways. All right, so we can see that if we take a look here, that we have a +1 pattern going on with the days that have passed, right? Which makes sense because the days increase just 1 by 1. And the snow is decreasing by 2, so -2, right? Okay, so we're going to keep that pattern going. We're going to add 1 to get to, oh, I'm going to change back to my correct color. Sorry about that. Goodness, there we go. Okay, so 4, and then I add another 1 to get to 5, and then to 6, and so on, right? So I'm going to just fill in a few of those, and then we are going to look again at the pattern of the snow, okay? So again, -2 is our pattern, right? We're decreasing by 2 every time, and so then I'm going to decrease 16 by 2 to get to 14, and then by 2 again to 12, and so on. Okay, so we're pretty close here. We're going to have to add a couple more, so 10 gives us 2 inches of snow, and then on day 11 we have none. Perfect. Okay, so then the reason that I'm not going to keep going, so I can't put a 12 here because can I have -2 inches of snow? No, that doesn't make any sense at all, so I cannot include that in my work. So that is the end of my graph. Okay, so then I'm going to take a look here. It says graph the table of values on the provided graph, right? So on this coordinate plane that I've provided, and then we're going to create an equation. So creating an equation you did in grade 9, and if you are having trouble with it, let me know. I have a couple worksheets on creating equations that you guys can practice off of, that I can just upload them onto our Teams. So let me know if that would be helpful. Okay, so again, when we graph, we always want to put that independent variable along the x-axis and the dependent variable along the y-axis. And so we talked about how the days that have passed is the independent variable because nothing can stop time, right? And then the inches of snow are the dependent variable. So the inches of snow that remain on the ground are the dependent variable. Okay, perfect. So now we can, again, plot some points, right, by putting some numbers along the graph. And again, I'm going to need to get a 0 value, or at least very close to 0, for both of the independent and dependent variables, because I can see that there's 0 here, and 1 is very close to 0. So I'm going to, again, make my corner value that 0, and then there we go. We'll go from there. Okay, so the days are just going up by 1, which is very straightforward. So I'm just going to increase the days by 1 up the x-axis, okay? And again, you can write all of them if you want, or you can not write all of them. That's fine too, as long as you include at least like 2 to 3 labels, okay? And then along the inches of snow, we know that we need to get to 20, and we need to go all the way from as high as 20 to as low as 0. So I want to include enough space to do that. So I'm going to go up by 2s on the y-axis, but again, if you chose a different value, if you wanted to go up by 1s, you would be allowed to, as long as there's enough space on the axis, oh my goodness, to fit that. Okay. Okay, and there we go. So let's graph those points now. Okay, I wonder actually, hang on. You know what? There actually are enough spaces for me to go by 1s for the snow, so I'm actually going to do that, okay? So, sorry, I'm going to redo this, so you might want to also. Okay, so I'm going to just go up by 1s. You're noticing that I'm only writing every other number, but I'm also going up every other square, okay? So that does the same thing, right? I am using every square is equal to 1 if you think about what would be in between. Okay. All right, so there we go. That's good. Now let's graph those points, okay? So I'm going to have to do a little bit of zooming in and out here, as you're going to see, but just bear with me while we do this. So I'm going to start with my first point, okay? That's days passed is 1, and inches of snow is 20, okay? So we're going to have that spot 120 that we need to graph. So that's going to be right here. Oh, goodness. There we go. Okay. Then, because I know the graph, I know the table of values, then I know that on day 2 there were 18 inches left, so I'm going to put a point at 218. Okay, and then I know after 3 days there were 16 inches left, so I'm going to put that, and so on. You're seeing the pattern develop, right? After 4 days there were 14 inches, after 5 days there were 12 inches, and so on, right until we get all the way down to the last day, which would be day 11, and we know that there's going to be 0 inches at that day, so we're going to end our graph when we get right down here to the bottom. Okay, so there we go. There are all my points. And again, just like the example we did in the last lesson, of course, there are going to be points all in between, right? Because in between day 1 and day 2, there's the night between day 1 and day 2, and snow's melting then too, right? So we're going to draw that line to increase connect all those points, not increase, sorry. Okay, and again, this graphing tool is so bad on this iPad. I'm so sorry, you guys. So just roll with it. Again, that's supposed to go through all the points. Pretend that it does on my graph, and make sure that you do that properly on your own. Okay, so there we go. We've done that. Now, we're going to create an equation. So you may or may not remember this from grade 9, but if you don't, that's okay. We'll go over it. Whenever we make an equation of a line, it's easiest to do it in the y equals mx plus b form. And the other way to think about that is y is equal to pattern times x plus starting point. Okay, and so in this case, our pattern, I'm going to use a couple different colors of highlighters here. Our pattern is here, right? -2, -2, -2. So we're always talking about the dependent variable pattern, okay? And then the starting point is where does the starting point happen? Okay, and so a little bit tricky thing here is that in this case, the starting point is always wanting to be when the dependent variable is, when the independent variable is at 0. So the starting point always happens when x is equal to 0. And so in this case, we want to look at the graph, and we're going to realize pretty quick here that is when x is equal to 1, right? So we don't have x is equal to 0 quite yet. So we actually are going to have to go backwards one step to get to that starting point. So what I mean is we need to go backwards 1 to get to 0. And so we're going to have to go backwards 1 time to get to the starting point of snow, meaning doing the opposite of the pattern so that we can find what would have happened the day before our first snow measurement. Okay, and so that means in this case that we would have had 22 inches of snow on the day before the first measurement, right? Because we know the pattern is that it's melting by 2 inches every day to get that day 0. Okay, so then I'm going to highlight that in green because that is what we're looking for the starting point. Okay, so let's fill that in. Okay, so we are going to have y is equal to the pattern, which is -2 times x plus the starting point, which is 22. Okay, so there we go. That is the equation of the line that we just drew. All right, let us go to the next page. All right, so how much snow is left on day 5? How do we know? So if we go back and look at the graph, we can see that, I'm just going to switch colors again, on day 5, there were 12 inches of snow left, okay? And so how do we know is because we are following the pattern that we found for the graph, okay? So 12 inches of snow were left on day 5. And then you can say that this information, information, there we go, follows the pattern. Okay, and then in the second example, you can just cross off how do you know, because the answer is the same as what we just did. It's that the information follows the pattern. And we can look for day 8 to figure out how much snow is left then. Okay, so day 8 is here, and we can see that there are 6 inches of snow left. Okay, so that's what we can write. Okay, perfect, done. All right, let's do the other word problem, and then we're going to call it a day on this video. Okay, so when planning a 2-day rock climbing trip, that's what we're looking at. A school is doing this, and they are wanting to know which company will be cheaper, I guess, or more economical, whatever way you want to call that or talk about that, to take the kids on this trip. Okay, so we're seeing that travel agency 1 charges the school $175 plus $50 per student, while travel agency 2 charges the school $250 plus $25 per student. Okay, and so we want to figure out which one is going to give the school the better deal depending on how many kids are coming. Okay, so independent and dependent variables. Let's talk about those first. Okay. So independent variable is one of the variables, and the dependent variable, of course, is the other. And so if you take a look at the question, we can see that the number of students that come is going to affect the cost, right? And so that is actually exactly it. Okay, so number of students affects the cost of the trip. Okay, and so because of that, the number of students is independent, and the cost of the whole trip, cost of the whole trip is the dependent variable. Okay, so let's take a look at the travel agency 1 and travel agency 2, and let's fill this in. Okay, so I'm gonna just switch some colors again here. If you can't see this yellow very well, just tell me and I can rewrite this lesson. Okay, so looking at this information, we can see travel agency 1 charges the school $175 plus a cost of $50 per student. Okay, so if there were no students coming, then this would cost them just $175 even. Now, if there's one student coming, then we're going to add $50, right? So then we're going to be talking about $225. Then if another student was coming, we're going to add another $50. So that's going to give us $275 in total. And so on, right? If 3 students, we're going to add another $50. That's going to get us to $325. And another student would add another $50, get us to $375. And I only went up to 5 because then we can get a good sense of the pattern already. Then at 5 students, then we're going to be paying $425 for this trip. Okay. All right, the next one, travel agency 2. Oops, sorry. There we go. Travel agency 2 charges the school $250 plus $25 per student. So that means when we have 0 students, let me just change colors again to kind of match the highlighters. Okay, when we have 0 students, the cost of the trip is still $250 just flat. Then when we add a student, we're going to add 25. Okay, so that's going to get us to $275. Then when we add another student, we're adding another 25. So we're going to get to $300. Wow, that was hard to write. Okay, and then again, so on. You see the pattern. So at 3 students, it's going to cost us $325. At 4 students, it's going to cost us $350, and at 5 students, it's going to cost us $375 dollars for that many students. Okay. All right, let's go on to the next page to talk about these. Okay, unfortunately, I couldn't get these both on the same page. I apologize for that, but we're going to graph this information down here. All right, so like we talked about, the number of students is the independent variable, and the cost is the dependent variable, so we're going to put those on our axes. Okay. I'm going to pick a totally different color than the ones that I'm going to graph with. Okay, so number of students is my independent variable, and total cost in dollars is the dependent variable. Okay, and I'm going to look back here, and I'm going to see that I need to have a 0 for the number of students, and I need to go up to 5 for the number of students, and for the cost, I need to start as low as $175 and make it all the way up to a maximum of $425, right? So $250 and $375 fit inside those numbers, so the lowest total cost is $175 and the highest total cost is $425. Okay, so we're going to make sure we get those on the graph. Okay. So, I'm going to start here with this number of students. Okay, so I'm going to do, again, the 0 in the corner. And then I'm going to just go every other spot. No, I'm not. I'm going to do just every square like normal. Actually, well, we'll see how this goes. I'm sorry if it gets messy, you guys. Okay. Okay, so number of students up to 5, right? In total 5. Okay, and the cost, again, like I was saying, is going to go up to a maximum of, let's look back here, $425. Pardon me. And so we are going to go up. I'm just going to decide this right now, and hopefully it works out. We're going to go up by $50. Okay, so this is 50, then 100, then 150, and then 200, and so on. Okay, I didn't write them all in because, again, I'm a little bit lazy, and you can kind of get the idea, right? So every notch is $50. Okay. So there we go. Okay, that looks good. Sorry, just making sure this is all good. All right, so now let's put those points. So we're going to put all of these data points here that we see, all of them, onto our graph. Okay, and so I'm going to just take a look here and start with the yellow graph, which, if you're wondering, I did the first one, the travel agency 1, in yellow. Okay, and I can remind myself of that by just putting like a little yellow square over here, color it in as best as I can, and say travel agency 1. Okay, and then I'm going to start plotting those points. So, at 0 students, the cost of travel agency 1 is $175. Okay, so is that, oh dear, there we go. Right there in the middle between 150 and 200. Okay, and then I'm going to do 225 is the next one, right, and then 275 and so on. So we're going to plot those points, and you're going to notice that we're going to have to do a little bit of estimating to get that in the middle there, but that's okay. I trust your skills. I trust my skills. We're good. That does not look like a good point, though. Let's try that again. Oh, my goodness. There we go. And then at 3 students, we have 325, and at 4 students, we have 375. There we go. And at 5 students, we have 425. Okay, maybe just going to add another axis label up here, just 500, just so you know where we're headed. Okay, and then we're going to do the finishing point of this line, which is to put a line through it. Okay, so let's see if we can get this to look pretty good again. Always a little bit of a risk with this program, this stylus. Okay, there we go. That's not bad. And then the other agency I did in green. Okay, again, just up here, a reminder, green. And I'm doing them in 2 colors so you can track which one is which when you look back on the notes. Okay, and again, I'm gonna just symbolize that by putting over here, travel agency 2. Okay, so this is like a double line graph, which we kind of talked about in our statistics unit, and again, you want to make sure there's like a little bit of a legend like this so that we always know what we're talking about. Okay, so travel agency 2. Let's start here. At 0 students, this costs $250. At 1 student, this costs $275. At 2 students, this costs $300. At 3 students, this costs $325. Oh, look, in the exact same place. At 4 students, this costs $350. And at 5 students, this costs $375. Oops. There we go. Okay, and again, I'm going to put a line through these points. There we go. Hey, not too bad. Okay, pretty good, actually. Perfect. Okay, so let us keep going. Okay, so if only 2 students participate in the trip, which agency would be cheaper? Okay, so we're going to look here. We're going to look at 2 students. Okay, and so we're going to figure out which agency was cheaper at that time. Okay, or at that number of students. So 2 students, we're going to see that it would be cheaper to go with travel agency 1, right? Because we can see that point is lower, and it only costs $325 instead of $350. Okay, and we can say only 275 instead of 300. All right, then we can look at if 15 students participated in the trip, which agency would be lower, and how do we know? Okay, so you're going to see here that our information stops at 5 students, right? But if you take a look at the lines, you can see that this line is increasing, and if I were to try to extend this other line, it would also still be increasing, but you can see that that second line is much lower, right? And so then by the time we get to 15 students, which would be maybe somewhere around like here, right? You can see that that green travel agency, or travel agency 2, would definitely be cheaper to do or to use as the company. Okay, so we are going to say agency 2 because the line representing cost is lower, so less. That looks like Tess. Less expensive overall. Okay. Okay, and what does it mean when the lines we graphed crossed each other? Okay, so we can see that again. We kind of pointed this out when we graphed that here at 325 they crossed, right? And so that's part of the answer. Okay, so they cross at 325. Okay, that's very messy. Let me try that again. Okay, and when they cross each other, what does that mean? If we take a look up here, there we go. Or actually, yes, sorry, up here, we can see that at this spot, that's 325, the costs are the same, but then after that, for 4 students, the costs start to differ again, right? And so that is exactly what this means. When they cross, that means the cost is the same for the trip. Okay, so there you go. That is it. All right, there we go. That's that lesson. I will do the remaining one in a following video. All right, talk to you ladies later.